Always wear gloves when handling sodium hydroxide. Refer to your lab procedure for the proper glassware, amount of sodium hydroxide, and amount of water required to prepare the sodium hydroxide solution. Stir the solution until the sodium hydroxide is completely dissolved. For the acid-base potentiometric titration lab, you will standardize the sodium hydroxide solution by titrating it with citric acid. Prepare the citric acid solution. For the KSP of KHT lab, you will prepare a saturated KHT solution. Allow the solution to settle. Use a clean stirring rod to decant about 80 milliliters of the solution into the 100 milliliter beaker. Try your best not to transfer any solid to the beaker. Transfer 20 milliliters of the saturated KHT solution to the flask. Do not forget to add the required drops of phenolphthalein to your KHT and citric acid solutions. Gently swirl the solution to mix. Fill the 10 milliliter graduated cylinder exactly to the 10 milliliter mark with your sodium hydroxide solution and record this as initial graduated cylinder volume. Use a clean pipette to add the sodium hydroxide solution from the 10 milliliter graduated cylinder to the acid solution a few drops at a time. As you titrate, gently swirl the beaker to mix the solution. As you add the NaOH, you will see a pink color appear and disappear as you swirl. As you continue to add sodium hydroxide, the pink color takes a longer time to disappear. This means you are approaching the endpoint of the titration. Add just one drop of sodium hydroxide at a time. This solution looks almost colorless but is faintly pink. Placing the beaker on a piece of paper will help you see the color of the solution. When you have reached the endpoint, return any unused sodium hydroxide solution in the pipette to the 10 milliliter graduated cylinder. Record the amount of sodium hydroxide solution in the 10 milliliter graduated cylinder as final graduated cylinder volume. This is the titrated acid solution. This is the solution one drop past the endpoint. Just 2 or 3 drops past the endpoint will make the solution a saturated hot pink. You will perform 2 more titration trials for both the KHT lab and the potentiometric titration lab. Make sure to record the temperature of the room for the KHT experiment. You should now have the values to calculate KSP of KHT. For the potentiometric titration lab, you should now have the values to calculate the average sodium hydroxide concentration. This is your standardized solution that you will use for the titration of vinegar using a pH meter. From your kit, locate the pH meter and the packets of buffer solutions, the 100 and 200 milliliter beakers, the 100 milliliter graduated cylinder, 3 medicine cups, and the glass stirring rod. You will also need labeling tape, distilled water, and a paper towel. To calibrate the pH meter, first prepare the provided buffer solutions. Measure 250 milliliters of distilled water and pour it into the 250 milliliter beaker. Empty the contents of the 6.86 packet into the 250 milliliter beaker. Stir to completely dissolve. This is the 6.86 buffer solution. Label a medicine cup with 6.86. Pour the 6.86 buffer solution into the medicine cup and fill to the 20 milliliter line. You can flush the excess buffer solution down the sink with plenty of water. Clean the 250 milliliter beaker and repeat the steps to prepare the 4 and 9.18 buffer solutions. Fill the 100 milliliter beaker halfway with distilled water and have a paper towel handy. Arrange the solutions in this order: 6.86, 4, and 9.18. Turn the pH meter on and insert it into the 6.86 buffer solution. The notch on the bottom of the pH meter is where the electrode is. Make sure this part of the pH meter is completely submerged in the buffer solution. Wait 15 seconds and allow the pH reading to stabilize. Press and hold the calibrate button for 5 seconds. The calibrate button is labeled CAL. The correct reading for the buffer will flash 3 times when the pH meter is calibrated. Rinse the pH meter with distilled water and dry with the paper towel. Repeat these steps for calibration at pH 4, rinse and dry, then calibrate at pH 9.18. The pH meter is now calibrated. Mix 5 milliliters of vinegar and 100 milliliters of distilled water in the 250 milliliter beaker to make your vinegar solution. Pour 100 milliliters of your standardized sodium hydroxide solution into the 100 milliliter graduated cylinder. Place the pH meter in the vinegar solution and make sure the electrode is completely submerged. Record the initial pH of the vinegar solution. Use a pipette to add 2 milliliters of sodium hydroxide at a time. Swirl the solution between each 2 milliliter addition of sodium hydroxide. Allow the pH reading to stabilize before the next addition of sodium hydroxide. Continue to add and swirl until the solution reaches a pH of 5. At pH 5, empty any sodium hydroxide in the pipette back into the 100 milliliter graduated cylinder and record the volume of the sodium hydroxide solution. Make sure you empty any leftover sodium hydroxide into the 100 milliliter graduated cylinder anytime you record the volume of the sodium hydroxide. Begin adding sodium hydroxide to the vinegar solution just 4 drops at a time until the solution reaches pH 9. Swirl the beaker after each addition of 4 drops. Allow the pH reading to stabilize and be very patient. It is easy to overshoot pH 9 even with 1 drop. After pH 9, take 10 more volume and pH readings by adding increments of 1 milliliter of base. When the pH is fairly constant, stop the titration. If the pH meter turns off during your titration, just turn it back on and continue titrating. Once you have finished your titration, you can flush all the solutions down the sink with plenty of water.